Hello, hello. Here is the video going over Unit 6 in preparation for your quadratics test. So the Unit 6 quadratics test covers writing equations for quadratics as well as solving quadratic equations. So the first question asks us, what are the three ways to solve a quadratic equation? Well, method number one is to factor it. So you can solve by factoring. Method number two is to solve by completing the square. And method number three is to use the good old quadratic formula. So solving by factoring doesn't work all the time because not everything is factorable. Completing the square is a little more tedious, but it does work for most things, particularly when a is 1, and the quadratic formula will work for anything. Number two, what part of the graph are you finding when you solve a quadratic equation that equals 0? What you're looking for whenever you're solving a quadratic equation is you are solving for the x-intercepts. So anytime you're solving for x, using either factoring, completing the square, or the quadratic formula, you're always solving for the x-intercepts. So that is where your graph crosses the x-axis, crosses or touches. So you could have something like this. You could have something like this, where it just touches the x-axis. Or you could have a quadratic that has no x-intercepts, that is just floating out in the middle of your quadrant, and that would have no solution. By the way, the first graph I drew has two solutions since it crosses your x-axis twice. Okay, the three forms of quadratics equations are below. The three forms of a quadratic are below. What part of the graph does each form tell you? So vertex form allows us to find the vertex fairly quickly. That's why it's called vertex form. Factored form allows us to find the x-intercepts quickly. And standard form allows us to find the y-intercept quickly. And you'll see a couple problems on your review finding all three of these things from the different forms. So let's go ahead and go to the next question, which will allow us to do some of that. So number 4 says write the equation of the quadratic that is graphed below in all three forms. So the first form we're going to look at is vertex form. Now in order to write the equation for vertex form, we need to know the vertex because that's what HK is. So if I look at my graph, I can see my lowest point right here at -6, -4. That represents my vertex. So -6, -4. So H is -6 and K is -4. And I'm just going to follow my vertex form right here to be able to write the equation. I am going to assume that A is 1 in this case. That way we don't necessarily have to verify it. But you should never really assume, but for the sake of simplicity, I'm going to say that A is 1. So I have x minus h, so x minus -6 becomes x plus 6 squared plus k, so plus -4 becomes -4. So there is your equation in vertex form. Factored form, we can write our equation by looking at the x-intercepts. So your x-intercepts are where they cross the x-axis. So I have an x-intercept at -8, 0, and another x-intercept at -4, 0. So if I have an x-intercept at -8, that means the factor that it came from was x plus 8. Similarly, if I have a 0 or an x-intercept at -4, that factor is going to be x plus 4, because it's always x minus your number if I look at my factored form on the side. So x minus your x-intercept. So x minus -8 becomes x plus 8. X minus -4 becomes x plus 4. Now, standard form is not really something that you can necessarily grab from the graph, but what we can do is we can use our factored form to get it into standard form. So I'm going to say standard form is a continuation of factored form. So what I'm going to do is I'm going to take my factored form and I'm actually going to multiply it out. So I'm going to distribute x times x is x squared, x times 4 is 4x. Then I'm going to distribute the 8. 8 times x is 8x. 8 times 4 is 32. I can go ahead and combine like terms. So I have x squared, 4x plus 8x is 12x, plus 32. And that right there is my standard form because I have it in this form over here where it says ax squared plus bx plus c. Whoops, didn't mean to draw that random line. Let me erase it. There you go. All right, next up, use the following equation, y equals x squared plus 4x minus 32 to answer the questions below. Now, I do notice that this right here is in standard form, and one thing that I had mentioned before on my first page is that standard form allows us to find the y-intercept fairly quickly. Because when you're plugging, so in order to find the y-intercept, you're plugging in 0 for x. I'm jumping to number 7, by the way. Plugging in 0 for x. So 0 squared plus 4 times 0 minus 32. What ends up happening is these two terms with the x's are going to disappear because you're plugging in 0. So your y-intercept always ends up being whatever your c value is, which of course I'm going to write as an ordered pair. So 0, negative 32. So that right there is my y-intercept. Now I jumped to number 7 because I did notice that it was in standard form, and standard form allows us to find the y-intercept fairly quickly. Now, in order to find the x-intercepts, what you are doing is you can really solve it 3 different ways. You can solve it using factoring, the quadratic formula, or completing the square. Because anytime we're trying to find our x-intercepts, we're setting our quadratic equal to 0. Now, one thing that I had mentioned before is that the x-intercepts come easily from factored form. So I'm actually going to take this and factor it. So I'm trying to find two numbers that multiply to 32 and add to 4. So brainstorming ways that multiply to 32. Well, I know 8 and 4 multiplies to 32. But it does need to add to a positive 4 and multiply to a negative 32. So I'm going to go ahead and make that 4 a negative. Now, since my a is 1, I can go ahead and jump straight to my factors, which I like to call double bubbles, and I can use these two numbers on the sides of my giant x to be able to set up my factors. So my first factor is going to be x plus 8, and my second factor is going to be x minus 4. In order to solve by factoring, or because this is in factored form, I can go ahead and easily find my x-intercepts from this one. It's going to be negative 8, 0, and from this one, it is going to be positive 4, 0. It ends up being the opposites because your a is 1. Okay. So now that I know my x-intercepts, I can go ahead and use that information to find the vertex. So one thing that we need to remember is that your vertex is right in the middle of your x-intercepts. So your axis of symmetry is right in the middle of your x-intercepts, and your vertex is always on the axis of symmetry. So what I want to do in order to find the x-coordinate of my vertex is I want to find the middle of negative 8 and 4. Well, you can do that a couple different ways. You can actually plot the points negative 8 and 4 and physically count to find the middle, or I can find the average of these two numbers. The average comes from taking these two numbers, adding them together, and dividing by 2. So negative 8 plus 4 is negative 4, divided by 2 is negative 2. So I know that negative 2 is right in the middle of negative 8 and 4. So that is my x-coordinate. For my y-coordinate, I can't spell. For my y-coordinate, what I want to do is I want to plug in the x coordinate. But where the heck am I plugging it in? I'm plugging it into my function. So where I see an x, I am now going to replace it with a -2. So I have x squared plus 4x minus 32. But of course, wherever I see an x, I am replacing it with -2. And then I can just calculate. -2 squared is 4 minus 8 minus 32. That gives me -4 minus 32, or -36, which of course you can always use a calculator instead of doing all this by hand. So that gives me -2, -36 for my vertex. I think my recording got cut off, so I'm going to start talking again. Once again, I have this number in front of my x squared, so I'm going to go ahead and see if I can factor it out first. So I'm going to see if 144 is divisible by 4. Got my handy dandy calculator next to me. 144 divided by 4 is 36. Yay! So that means my GCF is 4. So I can go ahead and pull out my GCF first. So I have x squared minus 36 equals 0. Now, this is a difference of squares, so it's similar to the last one that we did, where we had x minus 8 and x plus 8. This one, you can rewrite it as x squared plus 0x minus 36. So two numbers that multiply to negative 36 and add to 0 are negative 6 and positive 6. Anytime you're going to add to 0, these two numbers are going to end up being the same and opposite signs. So I can go ahead and jump to my double bubbles. X minus 6, x plus 6 equals 0. This first one is going to give me x equals 6. The second one is going to give me x equals negative 6. This 4 in the front, you don't really have to worry about since it doesn't have an actual x with it. So that's not going to yield any sort of solution. So we just have 6 and negative 6 from our factors. Number 12. Let's find two numbers that multiply to negative 54 and add to 3. Let's think. I'm going to go with 6 and 9 and hope for the best. 6 and 9. 6 and 9 does multiply to 54, so that's good. I'm going to make my 6 negative. Good. So negative 6 plus 9 is going to give me that positive 3. A is 1, so I'm going to jump to my double bubbles. X minus 6. X plus 9 equals 0. First answer is 6. Second answer is negative 9. Now, if you're watching this and you're like, I don't understand where the heck she's getting these answers, once again, it's because you essentially set these equal to 0 and solve. Add 6 to both sides. You get x equals 6. Subtract 9 from both sides. You get x equals negative 9. Okay, number 13. So I have this 3 in the front. Unfortunately, 10 and 8 are not divisible by 3, which means I need to actually deal with a coefficient of a that is not 1. So in order to do that, I'm going to multiply my first and my last term. That gives me 24. Now I'm going to go to my giant X. I'm going to put my 24 on top and negative 10 on the bottom. So make a little note to yourself for this particular problem. The factoring is a little more challenging than just jumping straight to your double bubbles, and that is because your number in front of x squared is not 1. So I'm going to go ahead and find two numbers that multiply to 24 and add to negative 10. Let's see. My brain instantly went to 12 and 2, but that's not going to work. 6 and 4. 6 times 4 is 24. 6 plus 4 is a positive 10, but I want a negative 10, so I'm going to make those both negative. All right. Now we are going to split the middle and factor by grouping. So unfortunately, since our a is not 1, the factoring is a bit more tedious, still doable, just a smidge tedious. So factoring by grouping, out of my first group, what do they have in common? They have a 3 and an x in common. Out of my second group, both of those numbers are divisible by 4. Since that's negative, I'm actually going to pull out a negative 4. So from my first group, I can pull out the 3x. That leaves me with x minus 2. For my second group, I can pull out a negative 4. And that also leaves me with x minus 2, because I'm dividing both of those groups by those GCFs. Now I can go ahead and get to my double bubbles. So 3x minus 4 and x minus 2 equals 0. This one is going to give me an answer of x equals 2. I can go ahead and do the opposite for that since there's no number in front of x. Be careful with this first factor. This one you do need to actually solve. The answer is not positive 4, so be careful with that. I'm going to add 4 to both sides. That gives me 3x equals 4. Divide by 3, and you get x equals 4/3. So my two answers are 4/3 and positive 2. Okay, so that was solving by factoring. Next up, solving by completing the square. So solving by completing the square is a totally different method. So the first thing you always want to do when you're solving by completing the square is actually to move your constant. So I'm going to start by subtracting 72 from both sides. As I rewrite, what I'm going to do is I'm going to insert some squares because it's called completing the square. So I like to use squares. Now, in order to figure out what goes in the square, I'm going to take half of my b and square it. It's always half of b. So a half of negative 18 is negative 9. Negative 9 squared is a positive 81. Okay. Now on my left-hand side, I can factor this. So two numbers that multiply to 81 and add to negative 18 are going to be negative 9 and negative 9. So that leaves me with x minus 9 squared. Lovely little shortcut. Half of b is always what's going to go into your factor. From here, negative 72 plus 81 is 9. Now I'm going to continue to solve. I'm going to go ahead and take the square root of both sides. On the left, that leaves me with x minus 9. Square root of 9 is 3, but anytime you are taking the square root, we need that plus or minus. That's going to allow us to get our two answers. So now I'm going to separate to get two equations. So I have x plus 9, or x minus 9 equals 3, and x minus 9 equals negative 3. Going to go ahead and solve both of these. First one, I get x equals 12. Second one, I get x equals 6. All right, let's do another one. For number 15, our c was already moved to the other side, so I'm going to go ahead and insert my squares. So I have x squared minus 6x plus my square equals 345 plus my other square, because I'm completing the square. Take half of b and square it. So half of negative 6 is negative 3. Negative 3 squared is 9. It's negative 3 times negative 3, and it is positive. Going to factor two numbers that multiply to 9 and add to negative 6 are negative 3 and negative 3. So x minus 3 squared equals 354. Friendly reminder, shortcut, half of b is what goes in the parentheses. Square root both sides. I have x minus 3 equals plus or minus. Most definitely need a calculator for this one. I don't know what the square root of 354 is off the top of my head. It's probably a decimal. Sure is. I'm going to go to one decimal place. So it is 18.8. I can go ahead and separate. So I have x minus 3 equals 18.8. X minus 3 equals negative 18.8. And we solve both of those. Add 3 to both sides. First one is x equals 21.8. For my second one, add 3 to both sides. And I get x equals negative 18.8 plus 3, negative 15.8. I feel like I could have done that with a calculator, but I didn't trust my mental math skills just now. But those are your two solutions for, what number is this? Number 15. Number 16, same thing. Gonna subtract 1 from both sides. Gonna insert my squares. Gonna take half of b and square it. Gonna factor. Here we go. So I'm taking half of 14 and squaring it. Half of 14 is 7. 7 squared is 49. All right, and we factor. Two numbers that multiply to 49 and add to 14 are 7 and 7, so x plus 7 squared equals negative 1 plus 49 is 48. And we square root. Again, I don't know what the square root of 48 is off the top of my head. It is not a perfect square, so I'm going to go ahead and use my handy dandy TI-84 and figure out what the heck that is, and it is 6.9. I'm going to go ahead and round to one decimal place. Don't forget your plus or minus, and we separate and solve. So x plus 7 equals positive 6.9. X plus 7 equals negative 6.9. Subtract 7 from both sides. You get x equals, again, I'm going to use a calculator because I don't trust my mental math skills, negative 0.1. I really should have known that. But again, I'm going to use the calculator just in case. Negative 13.9 for the second one. And voila. And that right there is completing the square. Method number 2 for solving quadratics. All right, method number 3. Good old quadratic formula. So first and foremost, let's write down what the quadratic formula is. It is negative b plus or minus square root b squared minus 4ac all over 2a. And that comes from standard form where you have ax squared plus bx plus c equals 0. Most definitely has to equal 0 if you're going to use the quadratic formula. So first thing you should do is actually identify a, b, and c. A is the number in front of x squared. So a is 1, b is negative 5, and c is 18. And I'm going to carefully plug in those three numbers into my formula. So this negative b right here essentially means the opposite of b. So if b is a negative 5, that means I'm going to use a positive 5. Plus or minus square root. And then I got my regular b squared minus 4 times a times c all over 2 times a. Now, I like to simplify what's underneath the radical before I take the square root. So I'm going to take negative 5 squared minus 4 times 1 times 18. And that gives me negative 47. Now, since I do have a negative underneath the radical, this is actually going to have no solution. Because you cannot take the square roots of negative numbers. They are not real numbers. They are imaginary numbers. And you'll learn all about imaginary numbers once you get to Algebra 2. But even if you did try to take the square root of negative 47, your calculator is going to give you a big fat error. So that means it is no solution. So essentially what this graph is looking like, I'm just making a guess here, is it's probably sitting in that first quadrant, just floating out there, not touching the x-axis at all. All right, number 18. So number 18, I do need to get this equal to 0. So I'm going to go ahead and subtract 3x squared from both sides. So I have 0 equals negative 3x squared plus 14x minus 7. And then from here, a is negative 3, b is 14, c is negative 7, and then we carefully plug it in. I'm assuming since 17 had no solution, this one is going to have a solution. But I want to do opposite of b, so negative 14, plus or minus square root b, that turned into a 1.4, didn't mean that. B squared minus 4 times a times c. Be careful with all these negatives. All over 2 times a. Make sure you are carefully calculating all of these. Plus or minus. Gonna figure out what the heck that square root is in a second. T times negative 3 is negative 6. And in my calculator, I am going to go ahead and evaluate 14 squared minus 4 times negative 3 times negative 7 gives me 112. And then I'm going to go ahead and actually take the square root of 112. What is that? 10.6. Okay, so now I'm going to go ahead and separate so I can get my two answers. My first answer is going to be negative 14 plus 10.6. I'm going to take that and divide it by negative 6. Second answer is going to be negative 14 minus 10.6 divided by negative 6. So I'm going to do negative 14 plus 10.6. Calculate that first. So I'm going to hit enter. It gives me negative 3.4 divided by negative 6. So that gives me 0.6. Answer number 1. Answer number 2. Negative 14 minus 10.6. Enter. That gives me negative 24.6 divided by negative 6 gives me 4.1. So here are my two solutions. All right, what's next? Describe when it would be best to use each of the following methods solving a quadratic. So I kind of talked about this at the very beginning. Factoring is always good if it's factorable. That seems like a stupid answer. I can't spell while I'm talking. Factorable. But if you recognize that something is factorable, factoring is probably the quickest way to be able to solve a quadratic. For completing the square, I like to do completing the square if A is equal to 1 and B is even. The key with B being even is because you are taking half of B, and it's a lot easier to take half of an even number than it is to take half of an odd number. And it does make it easier factoring-wise as well as you're completing the square. Quadratic formula really works for anything. I mostly like to use the quadratic formula if A is bigger than 1 or it's not factorable. Since it does work for everything. All right. Dexter is solving by completing the square. They made 2 mistakes somewhere in their work. Describe their mistakes. You do not need to fix it or solve. Okay, so let's think about what was going on in Dexter's head. For completing the square, the first thing you need to do is you need to move your C to the other side. So they did do that. Since they subtracted 28 from both sides. That's where this negative 28 came from. And then from there, they are completing the square. So we would take half of negative 18. So half of negative 18 and square it. So that's negative 9 squared, which is indeed 81. So the squares are correct. And then to get from here to here, they would need to combine the negative 28 plus 81 is 53, so the 53 is good. But you would also need to factor this. So two numbers that multiply to 81 and add to negative 18 are actually negative 9 and negative 9. So Dexter did not factor correctly. So that is mistake number 1. Mistake number 1, they factored incorrectly. Because it's actually supposed to be x minus 9 quantity squared. Okay, so that's mistake number 1. Mistake number 2, so what did Dexter do next? From there, I'm assuming they took the square root. So I'm going to use my calculator and see what the square root of 53 is. It is 7.3. So the 7.3 is good. However, every time you take the square root, you do need that plus or minus. That plus or minus allows us to have 2 answers. So Dexter only got negative 1.7. They should have gotten another answer, but their factor was wrong anyway, but they still should have gotten another answer. So mistake number 2, they forgot the plus or minus after taking the square root. Now, the directions for this question did say you do not need to fix it or solve, but sometimes when you're trying to identify a mistake that somebody makes, it's a little easier to just go ahead and solve it from the get-go and then compare what you did versus what this particular person did. And hopefully you don't make the same mistakes, because then you can identify what mistakes Dexter made. All right, so this concludes everything for this Unit 6 review. You can always rewind it, watch it again. I would recommend reviewing the pieces that are just super confusing for you and continuing to practice them as you prepare for this test. All right, good luck on your test.